Good evening. How do I get people? No? I don't know. Uh, Hello, everybody. Welcome so much. Ah, no, I got yeah, I got people's attention. Uh, Thank you so much for coming. My name is David. I'm one of the organizers of the Latinos in Tech group. Uh, Very excited to have you all here. We're very excited to have our speakers and Lumosity hosting us. The order of the night is it was a meetup. Tony first is going to tell us a little bit about Lumosity. Then we're going to have Luis have an introduction to machine learning and Laura, and there will be some questions. And then um, the event is going to be live streamed. So if you have things that you don't feel comfortable saying to people outside of the room, don't say them on out loud. And let us know if you need anything. And after the event, please do keep in touch. Our community is much more than events, so we want it to be much more than events. Join our Slack, join the community, find us if you have event suggestions or ideas, and yeah, get started.
Thank you. So hi, everyone. Welcome. Welcome to Lumos. I am Tony Anthony Garcia. I'm the head of product here for Lumosity. And hopefully you've all heard about Lumosity. If you haven't, feel free to download it, Android or App Store. But Lumosity is a brain training program. It's an adaptive brain training program on both iOS, Android, and web. And we're really excited to host this event focused on data science because our roots go back to very much thinking about brain training from the data science standpoint, thinking about the research that supports brain training and supporting a lot of academic research. And so from day one, data science has been an important part of the product we've built. And especially if you think about the fact that at this point in our history, we now have 85 million registered users. We have 35 million downloads. We're in 180 countries worldwide. And our product consists of close to 60 games now, and users have played over 4 billion gameplays. So our data set is really large. As a cognitive brain training data set, it's the largest in the world, and we make it available to researchers to use. But we're also using it internally. And so internally, we couple it with everything we know about users, all the profile information, demographics like age, gender, academic history, education, etc. Users are also sharing survey information via survey with us, like lifestyle choices, personality. And also we started coupling it with API integrations, like where users are connecting their data set in Lumosity with their Fitbit data sets and other data sets through APIs. And so this is a really exciting set of data that we have that we've been data mining, not only for research purposes, but also to think about how to present this information back to users. This is really exciting. People want to know, so my brain training performance, how does it relate to other people? What can you tell me as a holistic set of users, what trends you're seeing? If I do X, what does it mean to Y? Like if I don't sleep enough, what does it do to my memory performance? The question a lot of people have asked is like, do you guys have an integration with a breathalyzer? Like if I'm drinking, what does it do to different performance? But so yeah, it's a really fun data set. If you guys are interested, here's my plug. We have a lot of open positions on the data science team. It's a growing team, really important to what we consider our future, and it's very competitive. It's a big competitive differentiation for us. We are the largest brain training company, but we're also hiring across other teams in the company. We have open positions in product management, on our design team, and our engineering team. So if those things are of interest to you guys, our recruiters are in the back, raising their hands. And we also have a few engineers in the room at the moment. You guys are looking at Mark in the back in blue. So feel free to catch any of us after the event, and hopefully a few more people come up from downstairs. But welcome, a little bit of housekeeping. Please, there's pizza available for everyone. There's drinks in the back, restrooms around the corner. But that's all I have for now. So thank you.
Amanda. Oh, now you can hear me. I was going to say, Amanda, come help me with the, but now we're good. So you all hear me well? Cool. Well, hi, and thank you for having me. And thank you to David and Techqueria for running the show. Thanks to Amanda for setting this up, and to Tony for the nice welcome. Yeah, so what is machine learning? That's what I'll be talking about. So just to get an idea, who here knows machine learning or is familiarized? Can you raise your hand? Cool. It's an educated crowd. So yeah, if you don't know anything about machine learning, then hopefully you'll know by the end of this talk. If you know some, then you see a different angle. If you are an expert in machine learning, then fact checking is welcome, but by the end of the talk, please. So I'm wondering if somebody can actually tell me what is machine learning for you. Like, can anybody just take a stab at it? Any of the experts? Come on, somebody. Bueller? Yeah. Absolutely. Yeah, that's perfect. Look for patterns. Yeah, the way I see machine learning is trying to teach the computer how to think like a human. So I'll give you an example. This is a Tapatio bottle. So I'm a human, and you say you want to tell me how to get the bottle. So you just say, there's the bottle, go get it. So I go and get it, right? But if I'm a computer, it's not that easy, right? You have to program me. You have to tell me the instructions. So you have to be like, turn left for I equals 1 to 5, give a step, and then take the bottle, right? But what if I'm not here? What if instead I'm here? You have to be like, take a step, now turn left. Now, so it's a different set of instructions for everywhere I am, and that's not convenient. So we want to teach a computer to be able to get the bottle with just one instruction, that no matter where you start. So how do we do it? What we do is we play a game of hot and cold, right? You know that game? So I'm like here, I'm like, okay, how am I doing? Oh, you're cold. Okay, what about now? Oh, you're colder. Oh, that's not good. What about now? You're warmer. Oh, good. So then I keep doing that, right? Of course, you don't want to like always be telling me hot and cold. So what you want to do is you want to give the computer some parameter. You want to give the computer some metric of how it's doing. And based on that, the computer will know. So for example, the metric would be the distance. How far am I from the bottle? So I'll be like 5 meters. Or is metric system okay? Or should I turn it to Fahrenheit? Or okay. So I'm the computer, and I go, how far am I from the bottle? 5 meters. Okay. What about now? 5.4 meters. Okay, that's not good. What about now? 4.7 meters. Okay, good. So I keep doing that. And eventually, if I minimize the distance to 0, I get to the bottle. So what we want to do is we want to give the computer a measure of how badly it's doing. In this case, it's the distance. And the computer will try to minimize it because the computer knows how to minimize stuff. Sounds good? Okay, another quick example, gradient descent. That's actually what it's called. We're in a mountain called Mount Everest. You'll see why it's called Mount Everest. And we want to descend the mountain, but it's very foggy, like San Francisco is, a mountain and foggy. You don't really see much around you, but you want to descend. So what do? You look around you and you see, where is it that I'm descending the most? And in that direction, you take a step. And then again, look, where is it that I'm descending the most? In that direction, you take a step. And so before we're trying to minimize the distance to the bottle, now we're trying to minimize the height. So that's the part where the human has to think. You tell the computer, what is it that you want to minimize, and you minimize that. If you in calculus are in speaking terms, what you're really doing is you're taking the gradient or the derivative. You take the derivative of the height function, and it points in one direction. It tells you what direction you decrease the most. So here's a little animation of what's happening. You look at all your directions. You decrease. You go take the one that decreases the most. Then look again. Take the one that decreases the most. Until you minimize the distance, which means you solved your problem. Okay? So it turns out that this simple notion is basically the entire machine learning. And all we have to do is figure out that distance or that height or that error function and make the computer minimize it. And sometimes that's not that easy. So this is some applications of machine learning. You can use it to beat a human at playing Go. It's AlphaGo from Google DeepMind. You can use it to beat humans at playing Jeopardy. Quite badly, apparently. You can use it for programming a self-driving car, or many other things, detecting spam, stock market, medical field to find faces in image recognition, and it's all with that simple concept. And this is something that appears a lot in machine learning: neural networks. Show of hands, who knows what a neural network is or has seen it? Or cool. So when I heard neural networks the first time, I thought this. A friend told me, "Oh, this is neural networks. They think like the human brain," and I was like, I just picture like a brain in liquid somewhere with like claws. It's exactly what I pictured it. It looked pretty scary, but then I saw my first neural network, and I realized it's way scarier than that. This is horrendous. Okay. But then, and then we can look at the neural networks that are actually used. This is the neural network used for playing Go. Looks pretty complicated, right? This is the one used for self-driving car, or one of the ones. It's actually more complicated than that, but that's an idea. But I don't want you to think of neural network like this, because I don't think of neural network like this anymore. I think of them like this. Okay, to me, that's a neural network. You're on the beach, and there's a little kid playing, and there are some very fake-looking red shells and purple shells, totally not Photoshopped. They actually were there. I spent hours on Google image search. And you ask the kid, okay, can you draw a line in the sand that splits the red shells and the blue shells, or purple, I don't know, in two? And then the kid just goes, yeah, that's how you do it. Okay. Oh, sorry, that's the next one. And how do you do it? Well, in the same way, playing a game of hot and cold, right? You tell the computer how badly you're doing, and the computer just draws a line and then keeps trying and trying. Let's look at a little real life, or kind of real life example. Let's say we are a admissions office at a university, and we're trying to study the data and trying to figure out what to use to accept the students or not. So it turns out that we have two pieces of information: test and grades. Okay? And we're going to use these two to accept students or not. So we have student number 1 got 9 out of 10 in the tests and 8 in the grades. So that student gets accepted. We have student number 2 got 3 and 4. So that student didn't get accepted. And now we have student number 3 who got 7 and 6. And we're wondering if that student should get accepted or not. So we have to look, turn this into a machine learning problem. See what I did there? I plot the point at 3, 4 for the grades are 3 and 4. I plot this one at 9, 10. And we're wondering if the next student gets accepted or not in this grade. So we look at previous data, and it turns out that that's the previous data. All the green students have been accepted, and the red students have not been accepted. And so we see a trend in that data, right? Clearly, if you have more grades, better grades, or better tests, you get accepted, and if not, you don't get accepted. So here's a small quiz. Does our student 3 get accepted or not? What do you guys think? Yeah. Because you look at the data, and it seems like the kid that draws a line in the sand draws this line. That line separates the data pretty well, with some mistakes, but it doesn't matter. And this student is here, so they're well into the green area, so they got accepted. Okay. Now the question is how do we draw that line, right? What's the hot and cold game we're gonna use? This is called logistic regression. It's actually the simplest neural network. So let's just try to play the game we're playing with the bottle or going down the mountain. But now what we want to do is we want to draw a line that separates these 3 green points and these 3 red points. Okay. So the computer will start at somewhere and be like, I'm just going to draw a random line. How am I doing? And randomly, the computer is going to say, green area is going to be on the top and the red area is going to be on the bottom. So what seems like a good error function? What seems like something that I can use as my distance from the bottle or as my height in the mountain? Something that I can tell the computer, you are doing this badly. Any ideas? How much what? Yeah, it seems like there's one red point misclassified here, and there's one green point misclassified here. So I could just say 2, right? There's 2 points, two errors. So I can tell the computer, as the computer goes, how far am I? It's like, oh, you're too far. 2, not too far, but the number 2. And the computer will just play this game of going hot, cold, and then find that it can correctly classify one point, then do it again and correctly classify the other point, and then we get the solution. Does there look like I just tricked you? Like, does it look like something feel funny here? That's actually not the way to do it, but it's close. That's one, and that's getting there. That's the main idea of why not. If I'm here and I go, how bad am I doing? You go, 2 mistakes. Okay, what about now? 2 mistakes. Okay, what about now? 2 mistakes. It's hard, right? Until I find 1 or 3. The function goes 1, 2, 3. That's not good. I want a continuous function that goes, 2, 1.9, 1.85. That's what you want. You want a continuous function, right? So this function doesn't work, but it almost works. The one we're going to use is the log loss function. Okay, and let me give you a vague idea of how the log loss function works. What you want to do is you attach some value to each of the points, and the value is like a logarithm of something. I can't really write it down. I mean, I won't write it down for pedagogical purposes. I never remember it. But the fact is, the function gives you a large value if you're misclassified and a small value if you're correctly classified. It has to do with the distance from the line. So these points are punished for being misclassified, and these ones are not. And then I can play that game, because now I have a continuous function. Now I can be like, oh, and then I add them all together to get the total error. So that's a big error. We got 2 big circles. I play that game, and I start correctly classifying them. And now I get a much smaller error. So the computer can actually minimize that in the same way, in the gradient descent way. Is that clear? Any questions? Feel free to stop me with questions at any moment, by the way. All right. We're minimizing error using gradient descent. This is mostly to show off my animation skills. There's you in the mountain. The error is the red plus the green, and then you look at all the possible places you can go. You pick the one that decreases the most. You go in that direction. Then you do it again. You pick the place that decreases the most. Then you go in that direction, and you see you're classifying points correctly. So what do you think? Okay. So far, so good. But now, there's something's funny about this model, right? Is there anything kind of real life that we're missing here? Is there anything that you see that the model's kind of like not that good? A line? It's like, yeah, it's too straight. It's like, it's like building a wall. That's not a solution, right? Sometimes, if we look at this point, right, they did terribly in one of them in the grades, in the test, and then these points, you may need both frames, both pieces of data. You can't just be like you did very well in one and poorly in the other one. Like this points. Oh yeah, sorry. For example, this student 4, whereas it's a test equals 9 and grades equals 10. That person's over here, so they did very poorly on the grades, but they still got accepted. So let's try to fix that. Let's try to have these points, and we're going to say these points are going to get rejected. Okay. So now our model looks like this, which is more realistic, but at the same time it's harder because now I can't just draw a line. So what can we do? What's the next thing after a line? Circle works. Hey, circle. Hey, ooh, you guessed. Circle works. A curve, a hyperbola works. A parabola works. A lot of things work, and they're all found in the same way, by gradient descent. I'm actually going to go for 2 lines. 2 lines will do it, right? And 2 lines are, how do you find the 2 lines? In the same way of gradient descent. Just checking 2 lines, moving them around. That's actually a deep neural network. I'll show you why, okay? So here is, okay, I'm gonna show you why these 2 lines are a neural network. So a human can be like, oh, if I can ask a human, be like, hey, is this point in this positive region of the over the 2 lines? And a human can be like, yeah, sure. A computer is kind of dumb, right? Computer can be like, oh yeah. You have to ask the computer like a bunch, like 1 step at a time. You have to take a few questions. So it takes 3 questions for the computer to figure this out. Okay. The first question is the point on top of the blue line? Okay. And the answer, if I take my 4 black points as reference, yes for this one, yes for this one, no and no, right? The second question is the point over the orange line? And by over, I mean in the top side of it. It can be a little vague, but you get what I'm saying, right? Because you're humans, smarter than computers. The answer here is no for this one, yes for this one, no for this one, and yes for this one. What do you think is the third question? Exactly. Are the answers to questions 1 and 2 both yes? That's the third question, right? And here it's I get a yes and a no. It's like no. A yes and a yes is like yes. No, no is no, and no, yes is no. So there you go. With 3 questions, the computer figures out if a point is on the positive region of those 2 lines. Okay. Now let's kind of graph the questions just for fun. So question 1 is the point over the blue line. There's my area, right? And let's just do this. So one variable is test and the other one is grades, right? So here I have the node coming in and the node coming in, and this node here starts looking like that neural network I showed you. And what happens here is that this node kind of plots the point 1, 8, right? See, 1, 8, and checks if it's in the positive region and replies yes. There you go. That's a node. Second question is the point over the orange line. Same thing. I graph it like this. I put in my test and my grades. I plot the point. It turns out that it's in the negative region. So the answer is no. And then the next one is just simply a node. Oh, for the next question, are the answers to questions 1 and 2 both yes? Simple. You just take the AND operator. Okay, the AND operator says if you give me a yes and a yes, I'll return a yes. If you give me anything else, I'll say no. So there you go. And then the magic happens. Check it out. Ooh. See what I did there? And then you're just joining it, and that's the neural network. Let me clean it up a bit. Ta-da! So you have 2 inputs, test and grades. It goes through a middle layer of like checking if things are positive or negative in the region. And then this goes through AND. Let me clean it up even more. Ah, that's pretty. Is there anything here that sounds kind of like I'm halfway there? Like I'm not really like, am I missing something? Am I trying to trick you? Yes.
This is a neural network, but I can see that like a query. What would be the difference?
A query.
Query, yeah, from a database. If you are doing a query in SQL, you can have the same result for this.
Well, a query like breaks it down, right? So like, I'm not sure if I understand the question.
How is it different? Like,
no, this is very different. This is just the concept of a neural network, right? Like we're not using we're not querying things in SQL. We're just kind of like breaking down concepts too. So, yeah. Sorry. Yes. Yeah, but I mean, I can train a neural network by just putting like a lot of queries together or one by one. It's something more simpler, something conceptual. By gradient descent. I just go, are these 2 lines okay? No, hot, no, cold, like that. I just have to.
in that case, you're thinking of 2-dimensional, right? So you will be dividing the lines independently of each other. You have to
Yeah, but I just live in, like, if I live in 10 dimensions, right? I can move in 10 dimensions. So I'm moving 10 parameters, and each line is like 2 parameters or 3. So each line is like mx plus b, right? So I have the m and the b. So there's 2, and I move the other m and the other b, so that's another 2. So it's like living in a higher dimensional space and moving around. I can have as many parameters as I want. No, but it's very simple. So this baby is very reluctant here. What happens is that why are these 2 nodes checking if something's positive or negative in a region over a side of the line or not? And this is an AND operator. What the hell is an AND operator? So let me show you that an AND operator can also be seen as one of these red, green, put a line between operators. Okay? So here's my AND operator. Let's go very, very slow. Let's actually make a table of values. If you say yes, yes, the AND operator replies yes. If I say yes, no, the AND operator replies no. Help me out. If I say no, yes, no, and no, no, yeah, guess I'm on fire. Can we? Okay, so what's basically we know that a yes in computers gets recorded as a 1, and a no gets recorded as a 0. So let's turn that table into 1s and 0s. Hope nobody's colorblind, but basically this 1, 1, 1 goes to 1, 1, 1, etc. And let me show you an operator that will work, that will do AND in the same way as the other ones. Let me show you this operator. Okay, check this out. This is going to give me yes if you're on top of the if you're in the green region, and no if you're in the red region. So I take my 1 and 1, and I map this, and it's on the green region, right? And then I bring it back, and then that gives me a 1, and it goes down here. Oh, I like this. Then I take the 1 and the 0, and that gets mapped here. I'm loving this. And then that. Thank you, thank you. And this goes here, and I can keep going. I mean, anyway. And then this gives me 0, and then so you see how I turned the AND operator into an operator that checks if a point is over a line or not. There's my 0, 0. There's that. Ta-da! And now we have our neural network. There it is. Okay, you enter 2 numbers. The 2 numbers here, this checks if they're over a line. This checks if they're over a line, and then this outputs 2 numbers, 1 or 0s. And this checks if the point's over a line. Here, I actually even make an animation for that. Okay, my testing grades are 1 or 1 and 8. So that goes there. Then the yes gets activated. So this one fires a yes. Then these ones go here. Then the no gets activated. So this fires a no. We remember that yes is 1. We remember that no is 0. The 1 and the 0 go in. The no gets activated. And the answer is no. So if we have test equals 1 and grades equals 8, the answer is no. And again, how do you train this neural network? You started with 2 random lines here and a random line here, and just starts telling the computer how badly it's doing with the same log loss function that we used in the first case. Any questions? Does that make sense what a neural network kind of is? And then when you see this neural network, just think of this region. Okay? And now, so this is how I see logistic regression. This is just how I see things in my head. I see it as a ninja that looks at your data and cuts it in 2, right? And I see a neural network as a team of ninjas who will just look at your data and cut it into regions. Okay, so one last thing. When you see a neural network, you'll see some parameters. Have you ever seen this? The parameters that maybe you were asking about? How do we turn that into this pretty picture? Well, simple, right? A line is an equation in 3 variables. So check this out. What's the equation of this line over here? Well, it's (2x plus 7y equals 4). Okay, that's when I code this, I'm putting this line of this equation. And then anything in the green region is where 2x plus 7y is bigger than 4, And on the red region is when 2x plus 7y is less than 4. So that 2 and that 7 and that 4 are sort of my position when I'm standing in the mountain trying to minimize a function. That's kind of how if you picture higher dimensions, that's kind of what's happening. And now we can look at this and be a little less scared, right? Because what does this mean? You have a bunch of numbers, and you have a bunch of the numbers go through here, and each one of these nodes checks if the point is some positive region of some line or some higher dimensional plane. And then these things output numbers, and then these numbers going through another layer of like things checking if you're over or under a line or a plane, and then that goes through, and at the end you get a yes or a no or a things like that. Is that clear? And so now, why is it called neural network? Well, this is my mental picture that I try to in a brain which I know nothing about, so don't ask me questions. The brain cells have a lot of inputs of neural impulses that come from other brain cells, and then it just kind of like process it and returns an input. Here we have a brain cell that just grabs numbers and processes it and returns a number. So that's why it's called a neural network, because we're just concatenating brain cells. Okay. Now we can look at a self-driving car and see how does this work. Well, the car takes a picture of the road, and every pixel in the picture, it gives you a 0 or a 1 or some value if it's gray or something. So you can actually input all these numbers here. It's huge, right? It's 25,000 units, but you input a huge set of numbers. And then this layer in between just checks if things are on certain sides of a plane or not. And then this layer returns yes, go left, or no, go left, yes, right, or no, right, etc. So all you have to do is train this neural network by driving your car a lot of times and telling it what to do. The play and go one is a little more complicated. See how many layers it's got. But the input is your board, and the output is what to do. Okay? Any questions so far? Yeah, I think that was all. How am I doing with time? I think we can take a 3-minute break so people can get more beer. Okay. Good. Did I take too long, or I have no idea what I was doing? Okay. Okay. Great. Muchas gracias. This is my contact information. This is what I do for a living. I teach machine learning at Udacity. So you can go to Udacity ML, and you'll see me talking there. And then you can also, it's a machine learning class, there's self-driving car classes, there's all this cool stuff. Actually, they're coming out now, but it's part of it is this deep learning thing. Part of, I mean, there's a lot of like image recognition, stuff like that, like how do you detect a pedestrian. But the driving part of the self-driving car is a neural network. Yeah. So yeah, check it out. And that's it. Thank you. Yo no sé, yo tenía ni idea de la hora. ¿Cómo iba?
Son 7:46. No me acuerdo.
Me tomé mucho más.
No, pero nosotros no nos tomamos más. Yeah, like a 4-minute break, and then we can start again at 7:50.
Nice meeting you.
Laura. Check this out. It was like a super cool talk.
Thank you, man.
That was pretty good.
Thank you. Thank you.
I'm going over the board stuff. I don't have time to.
Hey, well, they said you need a nice good opening, so
Yeah.
forward to your talk.
That's how I program.
Yeah. It's like Q8.
Yeah. It's like, this is not what you should be doing.
To me, it's always been like black magic.
So we have this setup, and then we have hand mics.
Which order you prefer?
No, hand mic. Okay. I have another. That's better. Do you want an intro, or can you intro yourself? I'll take it.
Yeah, digamos 7:50.
Yeah, that's good. Okay, I'm gonna go get one.
No, I was telling my data science team, I was like, Luis could do an intro class to everybody that doesn't know. Like, we should just have every engineer start and be like, take Luis's class about what neural networks is what we think is important.
Thank you, thank you.
Yeah, it's good.
Yeah, I think a lot of this material, like I think a lot of explaining things properly, like the sort of most simplest way, because I myself never understand stuff when I see it talk. So I try to do
No,
it
it's actually
so that
pretty
I
good because
understand.
I'm going into the high level stuff on like
Yeah.
how
That's
Hadoop
perfect. When I
and
saw that you were talking, I was like, oh, good, that's perfect.
Yeah, it's
Because now
really
you talk about applications of what I do. And then,
yeah, so I was
Yeah.
like, this is perfect. And so then you were like, I was actually like, yeah.
Hello. Break is over.
And it's this.
I forgot to say one thing. Hi.
Sí, pero lo tienes que conectar.
Hi, I forgot to say one thing. I have a bunch of coupons for discounts on self-driving car class at Udacity. Actually, maybe coupons for everything, but please take. It's a discount at Udacity, so you.
Just put them over here, okay?
Thank you.
And the break is over.
And the break is over.
¿Sí funciona?
Hi, everyone. So, hi. Nice. Thank you, Luis. That was a very good introduction to a lot of boring stuff I don't think I want to go over. But you made it fun, so that's a good thing. You made it super fun. Like, I think my engineers should be taking this on, like, onboarding 101. So if I can get everyone's attention really quick, that'd be great. So anyway, my name is Laura Gómez, and I'm here mostly because I don't like being up here because I am a solo founder of a startup that should require all my attention, but mostly because David and CJ are amazing advocates, and for them, I would probably climb Mount Everest. So thank you so much for having me here. Hey, who am I? I was like the cutest little kid. And my username on Twitter is @Laura or @Laura if you speak English. So yeah, there's a long story. I was an early Twitter employee. Also, I look good in blue. I tell that to my sister, who still wears pink, and I still wear blue a lot of the time. I was born in Mexico. You can Google a lot of this stuff, about me, which is kind of weird when you're dating and you tell guys, don't Google me. And they're like, I totally Googled you. And I saw that in interview. Like you did with the HuffPost. Came here as a child. I was undocumented, grew up in Silicon Valley. Had my first internship at 17 at Hewlett-Packard. I've worked for YouTube, Google. I was the head of localization for Twitter. Now I have my own startup. It's all kind of cool. Yay. Guanajuato, Leon. Oh yeah. I see the resemblance of good lookingness. So I am so just happy with my life right now. Like everybody's like, why are you so happy? I'm like, oh my God, can you believe my life? I have a startup that's working. So I'm going to mostly talk about what we do at Atipica, but also like in the general scheme of things, like why I'm drawn to data science and why I'm here. Even though my whole career has been a lot of product management and localization. And yesterday I went to First Round Capital. If you've never heard First Round Capital, is very prestigious VC firm, and they have the CEO summit, and I got invited this year, and I went, and I took notes. I'm like, I'm gonna be the best CEO ever. And then I talked to this guy who was like doing localization, and I grilled him. I'm like, how are you doing double byte localization? So I love international, and I know 4 languages, so I'm a big fan of like product and localization, but right now I have to be the CEO of a data-driven company, which I love even more. This is where I look like a chola, mostly because like the Wall Street Journal told me not to smile, and I'm like, no, I want to smile. I'm like, I have a dimple. I should smile. Look at this dimple, and they're like, stop smiling. And so then they were like, just look up. And I was in my laptop, and then they told me to look up. And then my mom picked up the newspaper, was like, ¿Por qué pareces chola? Why are you looking like a chola? And I'm like, you know what? You should be proud I'm not in handcuffs. You should just be proud that I actually, yeah, I am with a computer. And you can buy Wall Street Journal, which you can tell the people you clean houses that your daughter was in the Wall Street Journal. And they're not. So that was me last year when Atipica, and I did not know that if anyone here is a founder or entrepreneur, ever has been or wants to be, it is one of the toughest situations I've ever been in my life. Also one of the most rewarding. So this is right after I started Atipica. I'm like, I have this idea, and I think it's really great. Not only am I part of Atipica, I put this in because I think this defines me. I'm part of Project Include, projectinclude.org, that allows an understanding of diversity in tech, more than just gender, more than just race, and how we can actually build a framework around it. Like, what does inclusion look like? How do you want to be happy when you're in a company for 3 years and you're about to be a mother, or you are over the age of something? So we are really trying hard to think about diversity and inclusion in a comprehensive framework, and to all, and obviously I told Ellen right now I was going to talk to Ellen because she led Project Include. I am the only Latina in Project Include. Also, I feel like it is really important. Between all of us women, we have 150 years of experience in tech. So we understand how it is to actually, if anyone watched the debate, to be shut down during a meeting and all of the stuff. So I am also part of Project Include, although like it's weighing down since I had this thing called investors. I love them all. Hey, you're live streaming. Hi, Tony. So I am part of Project Include. I think it's important for me to be part of initiatives, even though I am very tired and that represent the Latino voice, because sometimes our voices are not heard or are muted in the media. So thank you, Ellen, for giving me this opportunity to be part of Project Include. Also, Ellen, I think, is one of the most fierce women I've ever met in my life. Atipica. I'm not an HR tech expert. I was a hiring manager at Twitter, so I was there when there were like 40 or 50 people, and I left when there were like 3,000. So obviously, like my team grew a lot too. Someone 2 years ago calls me, and it's a reporter from USA Today, Jessica. I love Jessica. Jessica's like, we need you to be on a panel to talk about these numbers. Why are these numbers so low? And I'm like, I've been in tech like half of my life. Like, I don't understand why it suddenly matters. But everyone called me. They asked me to be in this awesome panel, who, by the way, I'm really good friends with the Reverend, and Nancy Lee from Google, and not here, Maxine William. And so someone's like, you should be on this panel so you can keep the Reverend in check. And I was like, but who's going to keep me in check? That's a kind of awesome question. And they didn't know this, and no one knew. And my mom was there, and my mom was like, you sabía that you're going to like say something that people weren't going to agree with. So a lot of it was they were focusing on the pipeline diversity issue, and I was like, that's great. If you want to focus on the pipeline, then you should focus on data-driven information and how that pipeline and whatever you've done throughout your life and where are the behaviors of the recruiters, and don't penalize the recruiters or the hiring managers. What are the things that are around pattern matching? And so Atipica was born out of that. We've actually become a holistic way of understanding how compatibility should look like. Whether you write your resume a certain way, where are the soft skills that you think that you're good, are there transferable skills? So I have a grand vision of Atipica. Why do I put this? Every time I pitch to investors and or clients, no one knew who invented the resume. The resume was invented 533 years ago by Leonardo da Vinci, and we still use it. And like LinkedIn became I gave a talk at LinkedIn like 2 weeks ago, and then we're like, we're going to acquire you. I'm like, hell no. LinkedIn became just a digitized version of the resume to keep promoting the same things that we should be putting, and people want to replace the resume. I don't think that we're ready for that, but I want to know the resume before we replace it. So thinking about the 533 years, and like people only have one chance to write something that someone else will read and interpret and say, you are qualified enough for me to even talk to you or even move into my company, which makes no sense. But to me, it's like, okay, let's try to interpret that. And that's where the data science comes from. How do we help our clients? And we have pretty good clients, I think. Well, we have really good clients. We do historical analysis. So we look at everything that they've done in the past, and we understand like, hey, like, there's unstructured and structured data. So the unstructured data is actually the resumes or the cover letter or anything that has text, right? And anything good will have an NLP parser. And parsing is amazing, but it's not everything. So what other interpretive factors can you make into it? And no one thinks about this in that way. How can we employ demographic models to think about how, if someone applies, I remember at one point we did a pilot, and we kept asking them, like, we've seen your recruiters recruit people from this zip code. And they're like, oh, we don't have commuter benefits. And I was like, and the recruiters didn't even know they were unconsciously doing that. So we understand like demographic models around things that are doing. We automatically review profiles. I think parsing, as I said, is one of the greatest things about AI and artificial intelligence, is how we can interpret that information. But that doesn't mean that's the only sole purpose of that information. We actually interrupt biases through different steps. I've had clients of mine, I'm like, show me the name. And I'm like, no, that is the most basic thing about interrupting biases, but we don't allow them to search through our product, so they can't search for keywords or say, I want someone that worked at Google, or I want someone this. Why? Because that is going to enhance their pattern matching. And all we want to do is work with the recruiters to think outside the box. And so instead, how can machine learning help them? And how can we understand that balance? So we don't allow a lot of behaviors that a lot of people in recruiting do. We do continuous matching. When I applied at Twitter, which I attribute and Ev and Biz, all the founders, and even Jack. Thank you for hiring me early on as the first international hire. But I applied to the wrong job because I didn't know enough to apply to the right job. And so when someone applies that doesn't have a referral, how can we continuously match them to the right job and say, hey, you applied for this other job, we're going to notify. So I think a lot of the things that we are doing is to equalize that field that right now is very hierarchical or nepotism in tech. Around data, what's up? So I was at Strata Hadoop. I was the only female founder at startup at Strata Hadoop, which is the largest data science conference there. I felt like a show I felt like an episode of Silicon Valley. I went there, no one talked to me. But also it was very amazing to meet and understand the power of data and data for good. Like I heard talks around like how human rights organizations are using data to save refugees out of Syria. So we think a lot about data, about the ownership and who has it and who doesn't. But it's much more about what can we do with that power and that information. And so I think that that's one of the principles in Atipica that we think about. Like we're going to have information about industries at any given point. How can we improve that? So I definitely do think that like data from a non-data scientist, and so Luis, thank you. Like I don't know how you do it, but as a non-data scientist, I'm the CEO. I just tell people like I want to find this. You guys get to find it. But I think data science is so powerful, and founding a company around data science is actually pretty amazing. I did not put you guys where we're at, which is not a scalable solution, but I obviously do think that in general we will have hundreds of thousands of clients. We will normalize that information through an internal API, and how we will process it throughout the block. Blocks would actually be into like having a different ways of algorithms and how we want to present that, whether it's licensing or matching or models, how we want to present to the enterprise, which is what we're doing right now. Consumers, do people want to be able to say, hey, I want to work in this industry, this is my resume, and we can say, okay, we've extracted things that you might be suitable for, tell us more. Because you can play all the games you want in recruiting, but it's only up to you to tell us your voice. Or either a platform, how can we enhance job compatibility? So I do think that a lot, and contextual algorithms, when I discuss contextual algorithms is meaning that everything shouldn't be in one, it should be all, there should be a lot of context around it, like what industry is this person applying to, where they're at, what is the industry is telling you, and the demographic right now, data scientists are the hottest thing. And so we're really trying to become the ways of employment of like, hey, if there's an up and down, you shouldn't be thinking about now, you should be thinking about strategically what this means for the next couple of years, whether you're a company or an employee. Some of the things, if you guys don't know, conditional random field, and thank you, my data science team, for providing this to me. It is really just training them on resumes, but we're not just training them on resumes, we're training them on specific types of resumes from specific types of people. So how can we do a CRF model for female engineers? How can we do a CRF model for Latino resumes in marketing in San Francisco? So it's really like having a CRF model that understands the different variations of what we're trying to do. And so I think that that's the first thing around data science that is really exciting, because I see competitors of mine trying to analyze all profiles and extract the same information, but no one's trying to interpret that information into meaning or value for anyone. It's for them, right? Like they think that they're the best because they came up with this great algorithms, which is the topic of my talk. Another thing is we penalize a lot of humans using our algorithms, mostly recruiters, they're clueless or anything. We don't do that. We want to give them training on if they're doing research on a C++ engineer, what other skill sets can they look for so that they can meet their hiring managers. And these are hard skills. We want to work with soft skills as well, whether it's sentiment analysis or anything. So we actually, if people publish a paper, we have it, we're going to try to implement it into our algorithms. And so I think that that's really important, is to try to provide some sort of context to the people using your algorithm. You should be empathetic. It should be accountable. And you shouldn't just try to give them an algorithm of like, we think that this is the perfect candidate. And that candidate may not be the perfect candidate for someone in a growing startup that has 100 employees. They may look for something else. So we look for a lot of context. So a lot of our clients are actually people that like, whether I've been there before, I'm like, oh, I've been in that situation. They're looking for generalists that can grow with their company. So we do try to provide a lot of context, both for the people using it and for the outcomes Why? Because we all see this, and we know that, actually, I think I've taught at every single one of these tech companies. Yeah, we understand the issues that arise from years of not having diversity or holding their algorithms accountable. And we don't want that. We don't want someone to be like, we use Atipica and we ended up hiring the same people for 10 years. No, we used Atipica and we ended up hiring people that were great for that period of the company. They stayed with us, they were happy, they moved on. And it's not a whole thing where we keep, and so holding, it's actually a really, really hard thing in data science is to hold your own algorithms accountable because we have historical data from our own clients. And so what do we take from that data that is valuable and what do we put aside? And just determining that, it is insane because like obviously that company has grown and has really great and wonderful people. So what are the things that we want to take and then leave aside? And then what is the training set that we want to give for the next period and for each month, for each day? So if a recruiter says, no, 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 do we flag this to the director of recruiting and saying, we've noticed that this happened? Or do we go with what the recruiter says? Because machine learning, as you learn, should go with how the human interacts and the machine. So it's a lot of like almost ethical decisions that are my team and I make every day. But we're thinking about it in the long run. I actually got this morning because I'm trying to I'm hiring, so FYI, Atipica.com. It's the fact that I actually don't look at resumes, which is funny. I have a resume review company. When people apply, well, I look at them and then I just let them, I'm like, I looked at your resume, but you tell me what your resume says. And this amazing human being that I think like, my friend was like, you get more excited about this person than you do about your boyfriend. Sorry, boyfriend, if you're watching. Is that I do think that it is, how can we help transferable skills? If someone's wanting to enter an industry that's really hard, what are the transferable skills that they have? I've talked to numerous of my friends that have been in non-tech companies and I sit them down and I'm like, say this, talk this. They end up being in tech and they're like, now I can help my family with their mortgage, etc. But I do think that one day, if God willing, Atipica can get to the point where we can actually look at the probability of transferable skills, where this person doesn't need to think that they have minimal experience, although I think she's overqualified for the role that I'm hiring her for. She's extremely overqualified, but in her eyes, it's because she doesn't have the correct experience within a startup. I do every learning lesson in what I do. Like a lot of my team didn't come from my network. A lot of my team actually came from me posting job descriptions on the internet and just having them. I wrote this Medium blog post around it because I don't think I'm going to eradicate biases. I'm not here to be every Silicon Valley CEO thinking, I'm going to make the world a better place, which I am. But I don't think I'm going to change the biases that we all have because we're humans. And so I just want a better version of that bias world. If our biases are going to be around, like, I like sweet foods rather than salty foods, that's a better bias than I like someone that went to Stanford versus someone that went to Alabama State, right? Cal. No, I went to Cal. That's much better. So I don't think that we're going to eradicate our biases because we're humans, and so I want my product to work with the humans, and I think we just have to have a better version. Obviously, not that version that Donald Trump has, like him. So yeah, but not that version. But I think it's the version of how our biases are working in everything that we're doing. So I do think that this is possible. I think that technology can get to that place. I do talk to a lot of founders that don't understand how they're building unaccountable algorithms. I'm like, but no, like I'm the best in this field. I'm like, but that doesn't mean that you know who's going to use this for the better. So you need to hold back on the product feedback. So I do think that we believe that. And I am 100% sure that every single person in my company believes that. How so? Like, I don't know. I'm actually, like, I ask him every day. So I had this senior director of SurveyMonkey who analyzed 70 billion responses, both structure and non-structure, which means when you check and then when you write. And he decided to join me, and I'm like, are you sure? You want to talk to my investors just to make sure? No, he joined me, and it's really like he believes that, like, the data, like he's analyzed so much data that he actually understands that data can be used for some sort of good or for some sort of empathy towards an algorithm. I can only be so lucky to think that I wake up every day and I'm like, I'm a venture-backed startup, which means that in my portfolio, in my lead investors portfolio, they have over 168 investments and only like about 8 are female founded. That I will get to wake up to that reality and this reality, and I'm like, I must make good use of the data behind it. So thank you. This is my email. Please email me. I'm hiring. And also ask me any questions. Actually, I would like any questions.
You get Luis up here too.
Yeah, Luis, ¿dónde estás? Ándale. Okay.
I kind of have an open-ended question for you. One is, could you speak about your pricing strategy for the platform that you have for B2C or B2B? And also, I was actually there at the summit yesterday as well. I was actually at the registration table, so I'm actually upset I didn't register you in. But I did get to listen to all of the speakers, and one of the interesting speakers was monetizing innovation. So that's why I'm the first guy that spoke. So I'm really interested to hear how you came up with your pricing strategy, and if he had anything to say about, for lack of better words, like a data-driven HR consultancy that you came up with.
So I don't have a lot of the pricing. Thank you, investors, for not pushing me for that. I don't think, like, I actually want to get to know, like, my first, like, well, I've had several clients, but in this phase of the clients where I can not think about the money or the revenue, where I can think about the value that I'm providing, I actually just,
Well, that's my question.
Yeah.
How are you able to?
I'm not. I honestly, like, I think that the majority of it is like, what value do they think that they're going to lose if they or gain? Okay, so if they have a job posting for a data scientist open for 20 days, and we have data for X amount of companies, we can tell them this is going to be not open for 20 days, it's going to be open for 25, and how we can alleviate. So right now I'm just focused on the value that I provide, because I don't need to focus on revenue because I have the investment. And so I do think that the pricing strategy is going to not be around, hey, this is a software, this is per seat. I don't care, because we're going to run the same models. Data science doesn't care how many seats you have. Literally, it's like, you will run the same job for 5 people or 10 or 20 people. I mean, the machine learning obviously will add to it. So for me, it's much more of understanding the value I can provide for my. But when I ever hit Series B, just call me.
No. Well, let me ask. Can I add on to that? How has the adoption been for those that actually value the value that?
Oh, they like it a lot, because they have no insights to it. Yeah.
Okay. People still believe.
No, I think people want knowledge. They don't want just data. Like, if you throw 1,000 numbers in front of them, they're like, okay, whatever. But if you throw insights in front of them, they're like, okay, that makes sense. So yeah, we believe in insights and value rather than numbers. Like, I literally could send all my clients right now a spreadsheet of all of their data. They will not care. But if I tell them this is what happened, and we Googled what happened in March when something this happened, and this is insightful, like, oh my God, that's true. And it's insights. Right?
there?
The question to Ruben. Thank you so much for your presentation earlier. A quick question about machine learning in general. So you mentioned that the more data that you have, it becomes easier to train these networks to get the right result. So in a world where we see a lot of companies focusing on different data sets and trying to solve different problems, does the company that has access to the most amount of data naturally have a competitive edge over smaller companies trying to tackle the same problem?
Yes. No, absolutely. There's a famous line in machine learning that says, that a bad algorithm with great data is better than a good algorithm with bad data. If your company has like tons and tons and tons of data, that's amazing because you can train all the models you want. You can predict anything. It's much better. Yeah. So
You get most data, how do you do it?
you just try to get more data. She knows more about it.
Question for you. It's hard, right? Like when I launched Atipica, I'm like, I'm gonna get all the data in the world by having a consumer product, and I had a web page. I'm like, give me your resume. I was like, I'm not gonna get to the data that I need here. I should sell enterprise where I can get large data. But that being said, I think that there's ways that you can say, okay, is the data that I want is 1,000? It can mechanical Turk or other ways help in that way. It is really hard to find your right. Like even us, like today I got asked like, what is our training data? Because we have to give it back to our clients if they decide not to. It's like, that's a good question. And so like having access to your training data that you can grow over time rather than replace it. It's hard, but I think there's several alternatives and you can start off small, like 1,000.
One thing that, for example, when I was at Google, many times we had the problem that a lot of data, like a complicated algorithm, would take too long, and a simple one with that much data would actually do better. It would actually do really well.
So kind of a follow-up question about data for Laura. So using machine learning applied to resumes is a hard problem, but also I think even harder is using machine learning for kind of culture fit and how companies screen for that. And so in your experience, what have you seen in terms of like insights from whatever data sets you've been able to collect about companies and their hiring practices when it comes to culture fit and underrepresented minorities?
Okay, so culture fit is literally the most bastardized word in Silicon Valley to think around. You don't fit, but we're not going to tell you why, and we're just going to exclude you until like you feel really shitty about yourself. So I don't think like I don't have. Thankfully, all of my clients have not had feel like we want. This is the employee we want. Also, mind you, and I can attest to it. I was the best employee at Twitter in 2009. I was the worst in 2013. I was like, oh heck no, get me out of here. Why? Because I was not a big company person, and so having culture fit as a proxy doesn't really make sense in hiring at all, because the business goals and the objectives, even for a large established company, let's say Wells Fargo. Mind you, if you apply as a salesperson at Wells Fargo now, it is a totally different proxy than it was 6 months ago. So I do think that for hiring for culture fit, people are seeing, their leaders are not seeing that, but that should be the proxy for anything. That being said, if someone tells you in a tech interview that you're not a culture fit, you should ask why. Why? What is the culture here? What are the values that I do not? And asking will actually let them think about it, like go back and be like, this, can it ask? Because it is the number one way of getting out of like, I don't see drinking with you on a Friday night around the foosball excuse. And you could be a woman, you could be pregnant, you could be all these other things, and you can not want to drink. Gosh, who does that? I want to go watch home. I want to watch Narcos on Netflix on Friday night. So I don't think I want to hang out with anyone who wants to do that. So I do think it's a proxy for the easy way out. I'm shocked that after the diversity things that are happening in Silicon Valley, people are still asking. Mind you, if they do, ask them why, constantly, including the hiring manager.
So when training your data, I'm assuming it's kind of hard to, you kind of touched up upon it a little bit when you were talking about, do you penalize, I guess, the hiring managers who are maybe passing on great resumes, or do you kind of use their decision as part of like the training data that you're going to use? Have you thought about maybe also following the candidate along once it's in your system, it goes through your through the process, a company possibly rejects the candidate, and then the candidate goes on to another company and gets hired somewhere else? Because I've known people who have applied to some companies, and I thought that they were great candidates. Somehow they got rejected, and then they got hired at companies that were clearly much better than the companies that got rejected at. And it's like these other companies were complete idiots for passing on these like great talents. So how can you incorporate that into your like algorithm so you can kind of like track that along and not just make that algorithm just be based on the decisions of possibly incompetent hiring managers?
So I actually want Luis to think where his regression tests and neural networks would work on this situation.
It's more from like when I've applied and the places have said no, and yes, it's kind of random. I mean, a lot of there's many like these algorithms. If you take them by faith, like they make a lot of mistakes. So you have to have a human component, like you were saying, right? You have to have insight. Just from that, I'll give you an example. If you just think of an algorithm, you may be able to minimize your function, maybe hitting the wrong minimum, right? You need to like try many different things, right? Try to train it from random places and things like that. And so yeah, it's human insight actually gives a lot more information. I don't know if I answered your question.
Well, I don't think we're there yet, but I think the world is like, where was that company at that point? Who was making those decisions? And like you can literally pinpoint to it. We don't exchange data. So like if you apply to one of the companies that are using us, Laura Gómez, to resume, we won't like say, hey, she applied to this other thing. Until we have a consumer product where we can confirm that. And like, Laura, we think that you may have applied for this. That being said, we think more than this flat LinkedIn connections of like someone's hiring, apply. There's a lot of context to it. And you can pinpoint that to the human. Well, like during this time that that several people applied under this leadership, under this CTO, under this manager, they were likely to not, be, and then, or were here. And it actually would be great for even the hiring managers to know, dang, I was a shitty ass hiring manager. I could improve. And so I think in general, it comes down to the decisions of the individual rather than the candidate themselves if they didn't get hired. So for us to focus on the candidate moving along a path wouldn't be the right training set. For us is to actually look at the conditions of the company at that time.
They go in the conditions of the company, which you possibly suggest which hiring manager would be best to interview a certain candidate.
No, because that's when we think that we know better than they do what the reality they look at, right? So no, like we don't want to replace them. I think we want to enhance the fact that like, hey, you're not making as many hires. Like, what are the things you're looking for? Tell us. So yeah.
Yeah, just to add, like an interview is like a very, very, very small window of you, right? So there's way too much variance there. So it requires like if the interviewer was having a bad day, if you were having a bad day, right? There's so many little things that you just not something you can predict very easily. So you just have to try luck.
I think David thinks that's only one question. Two more questions. Two more questions. Okay. I don't know.
Unless they're super long. Oh, that's another one.
My question is specifically for Laura, actually. So my understanding is that you started with a product manager background. How did you hire your first tech and data scientist person to start this very tech-related company?
It really had. So as a product manager, we know good, like, and driven technical talent, and I think the product management actually, like, okay, pinpoint. I built a prototype of remote talent in Mexico, and I honestly was like, I think I'm onto something. And I went, and I honestly like was very like, let's do something on Rails and do this. It ends up being that when you know you're onto something, you can prove a market fit, and then get the investment, you can just go. But I actually, even my data scientist and my AI guy, NLP, none of them have traditional backgrounds. And so I went against my gut instinct of like, I should get an NLP guy that has been doing this in rather see who's passionate about this and why. And so I got a civil engineer that worked at PG&E that transferred to data science. I got a biophysicist that realized Python is like the best thing in the world and decided to go into NLP. So I think I went with my gut instincts of passion before whatever they had done before, and it has worked for me because they think outside the box. An NLP scientist out of an Ivy League PhD will cost you, if not in 180 to 100K, but someone that is passionate about natural language processing, I don't know why, but thank you for my scientist that is, will want to prove themselves more and will be willing to just say, hey, give me a chance. And so I've told every single one of my hires, if we get to a Series A, you will all be compensated in market value.
Hi, my name is Ivan. So this is more focused about machine learning. So there's a interview that the last week, I think was the last week from Sam Altman to Elon Musk about artificial intelligence. I think artificial intelligence is the next step to machine learning. So Elon Musk says that one of the most scary things that he thinks for the future could happen is that the artificial intelligence could be handled for grown hands. So I'm sure government or a bad company. But my question is, what do you think about this? Why this could be a concern for the future if we don't have a good like handle of the artificial intelligence? How dangerous could be this? I'm not sure you have an idea about the future with this.
Wow, that's a good question. I don't know. I just I wonder. I mean, one thing that I wonder is when artificial intelligence can actually like make itself better, right? Like right now, I just used to solve problems like yes, no, or do this. But like if it can, at some point, you know, use the right function and be like make itself better, like instead and start to evolve. I think that would be kind of scary. It's to be kind of cool, but I don't know. I think I'm in the same place as you. I wonder.
I don't think artificial intelligence. I think like a lot of people feel like that there's going to be this robot matrix that takes over a lot of stuff, and I don't think so. I think it will be a very complementary as long as the industry that creates it keeps it in check, right? Like I wouldn't take an Uber self-driving car right now. I wouldn't take one because I don't know if I trust it. There's a sort of check. But talk to me in 10 years if there's some sort of check where I feel comfortable in that line. So I do think artificial intelligence is not this whole thing that we are so afraid of, but rather it's like, who's going to keep it in check? Because as you said, it's just they're making equations, and they're going to make equations better and more exponentially than our brains will do. So who's going to keep those things in check? And I think that's the scary part, right? That's the part where we don't know where things are going to go, and we just let the artificial intelligence. If someone somewhere that's reading that says, okay, if you decide to go crazy, like this is the shut up point. But I don't know if that's even possible. Like it is really hard to keep an AI algorithm in check. I know. I ask my engineers every day and they're like, oh my God, can you stop? This is really tiring. This is going to be half of our jobs. It is really hard.
Those remarks. Thank you all so much for coming. We have until 9 to be around here, so finish the pizza. I guess round of applause for our speakers who are amazing. You can continue talking to them here or join our Slack and Facebook groups. There's a lot of cool conversations there, and we'll hope to see you again next month.
And a round of applause to the organizers.
Oh, yeah.